Hi everyone, my name is Lydia, and this is what I wish they taught me about econometrics in introduction. In the previous video, we saw that reverse causality creates endogeneity. Now, let's make that visible with a path diagram. Keep in mind, you've already seen this visual language in the omitted variable bias video. The diagram will look familiar, and that's intentional. Endogeneity will always tell the same structural story, just through different channels than what you've seen with omitted variable bias. So let's start with that. In an ideal world, you would have a diagram that looks X, let's say education, this direction, this is my beta 1, Y, which in our case, let's say it's income. Okay? So this is the world OLS assumes one causal direction, clean, simple, from X to Y, measured by these beta 1. Our original model would have been Y equals to beta 0 plus beta 1X plus some error term U in there, okay? And this beta 1 has the clean causal interpretation. X changes, Y responds. Nothing that feeds back, okay? This is also the world of a randomized experiment. So random assignment ensures X moves independently. No feedback, no contamination. Now, what happens is that in the real world, this is not always the case. Reality is more complicated. The relationship runs in both directions simultaneously. So apart from this direct black arrow, there's actually another arrow that runs in this direction, and it's giving feedback here. Okay, so examples, we've said expected future earnings affect how long people stay in education. Or if we want to take the other examples we mentioned in the previous video, healthier people are more able to exercise, or high crime areas attract more police deployment. So in each case, what we thought was the outcome is also shaping the input. Now, this is why at this stage now we have a diagram with two arrows. One for the causal effect that we want. This is the beta 1 we want to estimate. And the other one is for the feedback that we don't actually want. And the problem is these two OLS cannot separate them. Now, let's add another term to this diagram, and that is the error term U, okay? The error term U, the arrow goes in this direction, okay? The error term contains everything affecting Y that is not in our model. So ability, family background, motivation would all be in that U. On its own, this is completely fine. U affecting Y is expected. That's what the error term is for. Now, the only problem that we see so far in this graph is the red arrow of the feedback, okay? The problem begins when now you also have the addition of another arrow, one that goes from the U to the X, okay? And what that means is that the covariance of X and U is actually not 0, okay? If Y affects X and U affects Y, what that means is that U indirectly affects X through Y. So let us write that down, because this particular loop that I just said right now, it's at the basis of the solution that we have come up with for reverse causality, okay? So if Y affects X and the error term affects the Y, then the error term U affects X through Y. Okay, so in fact, this particular orange line, we can also do it like a dashed line, because in fact, this shows because the blue line that we see in here goes through Y, through then the feedback arrow in here into education, which, as you will notice, is slightly different from what you have seen in OVB, because in OVB, the orange arrow was like a direct relationship, because there was indeed an X2 that was correlated with your X1, okay? So there is now this indirect connection between U and X, and that connection is the source of the endogeneity. And this is also the key logical step. The feedback loop that has created now has this back channel between U and X that OLS unfortunately cannot see or cannot account for. All right, so let's label it again, this feedback channel, and the dotted path that we see in here, this dotted path, this is the problem. And again, remember, it is dotted because we've got this indirect effect, okay, which goes through this feedback channel. Keep in mind, the differences and the similarities that you see with the omitted variable bias diagram and the endogeneity diagram in here have as consequence the same outcomes. So OLS is biased and inconsistent. And in a sense, this is also why endogeneity is the unifying concept between the two. Whether it's omitted variable bias, reverse causality, or we'll see later on measurement error, they all create the same forbidden connection between X and the error term. And they all require the same type of solution in a sense. You have to somehow control for or split these two effects from one another, okay? Now, why the OLS fails based on this diagram? Let's see it not just through intuition as we did in the previous video, but now that we have all the arrows, let's see like why it's failing in here. OLS is seeing X and Y moving together. However, it cannot really dictate that X is moving this much because of Y and Y is moving this much because of X. Instead, what it's going to do is attribute everything to this beta 1 in here, mixing both directions into one number. Okay, so the estimate is not causal, and in fact is the causal effect plus this feedback that is hopelessly, let's say, tangled in this effect. Okay, so what would be the fix? Based on this diagram, we know which is the arrow that creates the problem. So let's take this graph below with us and come up visually with the solution before we see actual examples. So we know that the problem is the orange line. So what we need is get rid of the actual problem, meaning we have to make sure that the orange line that was the problem no longer exists there. And the way we do that, because we cannot really delete this feedback channel that we have in here, we instead come up with a variable Z, which is your instrument, that has an arrow directly to the X, and keep in mind, there is no arrow that connects the Z instrument into the U. So covariance between the Z and the U, that is equal to 0. Okay? This is the preview of the solution. So what this will do is it will move X, but it's completely untouched by the feedback channel that goes U, Y, and X. So this variable, again, called instrument, and you will have to make sure that you always find a good one, will be the central challenge of a new type of estimation that we will call IV estimation. Okay, so Reverse causality creates this feedback path, error term yx that violates the fact that covariance of x and the error term is 0, and a valid instrument breaks this path by providing clean variation in the x, okay? So this provides clean variation in x. In the next video, we'll introduce the instrument, what it is, where it comes from, and what conditions it must satisfy. So stay tuned, and I'll see you in the next video.